Welcome to Gantrail. This video has been created to assist with the training and understanding of aluminothermic welding and the many benefits this can deliver. Filmed whilst daily port operations were underway at Southampton Container Port in England, this project for DP World will expand their port capacity by enabling larger cranes to be used on the newly installed third rail. Aluminothermic welding was first developed for joining very large sections of ferrous metals, and when continuous train rails were introduced, this method became commonly used for welding rails in the field. Its use in crane rail welding has become more common in recent years, now that the process has been easier to use and less operator dependent. However, as with any other specialist technique, aluminothermic welding still requires trained and skilled operatives. The many benefits that this style of welding delivers include the following. The actual welding process is dependent on a pre-packaged consumable. This in turn controls the metallurgy of the final weld once the initial preparation has been correctly completed. The whole process is quicker than traditional welding for larger rail sections and can often be completed in less than 1.5 hours. Reduced man-hours result in reduced disruption on site and ultimately a saving on overall costs. Gantrail have a long-term commitment to the welding of crane rails into continuous lengths. For almost 50 years we have promoted the system of welding rails where it is practical to do so. Aluminothermic welding is just one of the methods that we use, and this video serves to outline this process, which we believe offers measurable benefits to all concerned. Chapter 1. Rail Preparation. Before starting, ensure that the rail is suitably elevated, ideally mounted on timber or similar material giving you clear access. Using a wire brush, clean the ends of the rail to remove loose scale. This is extremely important preparation to ensure a high-quality weld. Then position the rail, setting the appropriate gap for the profile using the spacer block. The gap is determined by the spacer and can vary from rail to rail. In this instance, a gap of 25 mm has been applied. But on larger rails, a gap of up to 40 mm may be required. For more details on gaps, please refer to our website. Chapter 2. Rail alignment and joint setting. Here we see the setting of the line and peak of the rail using wedges and a 1 meter long straight edge. We recommend peaking the rail to a gradient of 1.5 mm in 500, either side of the joint, whilst also ensuring that the underside of the rails are flush with each other. Once the gap, line and peak have been set, the joint is secured by clamps and ready for the mold preparation and fitting. Chapter 3. Mold Preparation and Fitting. The bedding in of the mold and base plate is a crucial stage in the process. Once complete, luting paste is applied to the base. Next, clean the mold, making sure that the hole is clear of debris. The bottom plate is then raised to the underside of the rail. Next, fit and secure the mold. Please note that only one person should make the adjustment to ensure that the correct pressure is applied once tightening begins. During this stage, please make sure that the plug fits. Once satisfied, remove the plug. Chapter 4. Mold Sealing. Seal the mold with paste, ensuring that you have a good and strong seal. Then fit the slag pans. Chapter 5. Preheating. Set your torch to a predetermined height. This height will vary depending on the rails you're working on. For details on heights, please refer to our website. Then set your gauge at the correct pressure for preheating using oxypropane. Please note that only oxygen and propane must be used.
Oxy on.
Dry out your slag pans and surrounding steel, then set your torch on full in the center of the molds. On this project, the preheat stage lasts for 18 minutes. However, please be advised that preheat times can vary depending on the particular rail profile. Again, refer to our website for more details. Once the preheat temperature has been reached, reinsert the plug. Place the crucible on the center of the mold, then light and insert the igniter. Molten metal fills the joint and overflows into the slag trays. The removal of the crucible and slag trays should be done immediately after the flow to facilitate the shearing process. Chapter 6. Stripping and Cleaning. After the mold shoes have been removed, the process of cleaning the excess debris from the joint can begin. Chapter 7. Shearing. After the designated time, remove the excess mold using hydraulic shears. Again, refer to our website for more details. Grinding will be required to smooth the joint. After this point, the rail is ready to be lowered back into position for final alignment. Chapter 8. Completion. This video has clearly demonstrated a strong case for the use of aluminothermic welding on a heavy crane rail at a busy international port. Rails have been placed in alignment and level to take into account welding shrinkage factors. A disposable mold has been fitted and fastened to the rail, being then sealed against the possible leakage of molten steel. The rail has been preheated to the required temperature in line with the chemical composition of the rail and the consumables supplied. The combined portion and crucible have then been placed over the mold and fired. The molten metal has flowed into the mold and been allowed to cool sufficiently to meet the solidification requirements and integrity, but to also enable the removal of the excess metal from the unit. The weld has then cooled, cleared of runners and risers, and been dressed to take the crane wheel. Aluminothermic welding is a straightforward process and is easily performed by 2 experienced workers. However, to achieve the highest possible integrity of the weld, training, skill, and backup are essential. This welding process has been in use for almost 100 years and has been used for crane rail welding for decades. However, in recent years, the methods and materials used have improved greatly. This has predominantly been in response to increased integrity requirements in rail and industrial applications. The disposable elements of the process, namely the crucible and combined portion, are extremely straightforward to use and have also cleared the way for easy shipping throughout the world. Gantrail are experts in aluminothermic welding and all welding methods. It is our intention to apply the most up-to-date and innovative processes to all projects. Our extensive experience throughout the world positions us as the perfect partner for welding operations, including training services, materials provision, and on-site supervision. Gantrail, a world of crane rail expertise.